Hi everyone, glad to see you again. Today we have something informative lined up for you. If you like my video, don't forget to share and subscribe, and for more tech insights, stay safe online cyber defense. The world of cybersecurity is a fascinating one. It's a world of digital fortresses and ingenious minds constantly trying to outmaneuver each other. On one side, you have hackers trying to exploit vulnerabilities. On the other side, you have ethical hackers, the guardians of the digital realm. Ethical hackers use the same skills and tools as malicious hackers, but with permission and good intentions. They find and responsibly disclose security flaws before they can be exploited. This helps make systems and applications more secure for everyone. Ethical hackers respect privacy, seek permission, and disclose vulnerabilities responsibly. This commitment to ethical conduct separates them from malicious counterparts. Kali Linux is a Debian-based Linux distribution designed for penetration testing and digital forensics. It's a treasure chest of tools, pre-packaged for security professionals and enthusiasts. Imagine having a Swiss Army knife for cybersecurity. That's Kali Linux. It comes equipped with hundreds of tools for specific tasks in the hacking lifecycle. Its open-source nature makes it popular. The source code is freely available for inspection, modification, and distribution. Kali Linux is free to use, accessible to everyone from students to professionals. It can be installed on a computer, run from a live USB drive, or used within a virtual machine. This flexibility makes it adaptable to different needs and environments. Whether you're a seasoned tester or a beginner, Kali Linux is versatile for your cybersecurity journey. Before we dive into the exciting world of Android app hacking, it's crucial to set up our environment correctly. Think of it as preparing your workshop before starting a project. Kali Linux, with its user-friendly interface, makes this process straightforward. First, ensure your Kali Linux system is up to date. This is vital for leveraging the latest tools and security patches. Next, we need to install the necessary software packages for Android app testing. Kali Linux simplifies this process with its package manager. A few simple commands will equip you with tools like ADB or Android Debug Bridge and JDX, a powerful decompiler for Android apps. These tools will be our trusty sidekicks throughout our journey. Once the essential tools are installed, it's time to configure our Android device or emulator. We'll enable developer options and USB debugging on the device. This allows our Kali Linux system to communicate and interact with the Android environment. Think of it as establishing a secure bridge between your computer and the Android device. Now, with our Kali Linux environment prepped and our Android device ready, we're ready to explore the fascinating world of Android app security. Remember, our goal is to learn how to identify and ultimately help developers fix vulnerabilities. Kali Linux provides a powerful arsenal of tools specifically designed to assess the security of Android applications. These tools range from disassemblers, which allow us to peek under the hood of an app, to fuzzers, which bombard the app with unexpected inputs to identify weaknesses. One such tool is AppTool. Think of it as a master key for Android packages, or APKs. AppTool allows us to decompile an APK, giving us access to its inner workings. We can then analyze the app's code, resources, and configuration files, looking for potential vulnerabilities. Another indispensable tool is Burp Suite, a powerful web application security testing platform. While commonly used for web applications, Burp Suite's interception capabilities extend to mobile apps as well. With Burp Suite, we can intercept the communication between an Android app and its back-end server. This allows us to analyze the data being exchanged, identify potential security misconfigurations, and even test for vulnerabilities like SQL injection and cross-site scripting. Understanding how these tools work is key to performing effective security assessments. Vulnerability landscape, common pitfalls in Android apps. In the vast landscape of Android applications, certain security vulnerabilities tend to appear more frequently than others. These vulnerabilities often stem from common coding oversights, misconfigurations, or a lack of awareness about secure coding practices. One common vulnerability is insecure data storage. Imagine an app storing sensitive user data, like passwords or credit card information, directly on the device without proper encryption. This data could be easily accessible if the device is lost or stolen. Another prevalent vulnerability is improper input validation. If an app doesn't properly validate user input, it could be susceptible to attacks like SQL injection, where malicious code is injected into data inputs. This could potentially grant attackers access to sensitive data stored in the app's database. Understanding these common vulnerabilities is crucial for both ethical hackers and app developers. For ethical hackers, it helps focus their testing efforts on areas most likely to contain weaknesses. For developers, it provides valuable insights into secure coding practices, allowing them to build more resilient and secure applications from the ground up. A step-by-step walk through your first Android app penetration test. Let's walk through a basic Android app penetration test. First, procure the APK of the app. Use AppTool to decompile it. This gives access to the app's source code. Analyze the files for vulnerabilities. Use Burp Suite to intercept app traffic. Check for sensitive data in clear text. Document findings and recommendations. Ethical hacking is about responsible disclosure, beyond the basics, advanced techniques for seasoned pen testers. As you delve deeper into the realm of Android app security, you'll encounter more sophisticated techniques and tools. These advanced techniques often require a deeper understanding of mobile operating systems, reverse engineering, and exploit development. One such technique is dynamic analysis. Dynamic analysis involves running the app in a controlled environment and observing its behavior in real time. Tools like Frida allow us to inject our own code into a running app, giving us unprecedented control over its execution flow. This allows us to bypass security checks, manipulate data, and gain a deeper understanding of the app's inner workings. Another powerful technique is fuzzing. Fuzzing involves sending a large amount of malformed or unexpected data to an app's inputs, hoping to trigger unexpected behavior or crashes. These crashes often indicate underlying vulnerabilities that can be exploited. Tools like AFL, which stands for American Fuzzy Lop, and libfuzzer are commonly used for fuzzing Android apps. Mastering these advanced techniques requires dedication, practice, and a constant thirst for knowledge. The world of cybersecurity is constantly evolving, and staying ahead of the curve requires continuous learning and exploration. The Developer's Checklist: Best Practices for Secure Android Apps. Building secure Android apps is not just the responsibility of security professionals, it's a crucial aspect of the software development lifecycle. By incorporating security best practices from the outset, developers can significantly reduce the risk of vulnerabilities and create more resilient applications. One fundamental principle is the principle of least privilege. This means granting an app only the permissions it absolutely needs to function. Overprivileged apps pose a greater security risk, as a compromised app would have access to more sensitive data and functionalities. Another crucial practice is input validation. By thoroughly validating all user inputs, developers can prevent a wide range of injection attacks, such as SQL injection and cross-site scripting. Data encryption is paramount for protecting sensitive information. Encrypting data both in transit and at rest ensures that even if a device is compromised, the data remains inaccessible to unauthorized parties. Finally, using secure communication protocols, such as HTTPS for network communication, ensures that data exchange between the app and the back-end server remains confidential and tamper-proof. By embracing these best practices, developers can play a proactive role in creating a safer and more secure Android ecosystem. Conclusion: embracing ethical hacking for a safer digital world. As our journey through the world of ethical hacking and Android app security comes to a close, it's crucial to remember the importance of responsible disclosure and the ethical use of these powerful tools. The knowledge we've explored can be used for both good and malicious purposes. By embracing the principles of ethical hacking, we can use our skills to make the digital world a safer place. By identifying vulnerabilities and responsibly disclosing them to developers, we contribute to a more secure and trustworthy digital ecosystem. The world of cybersecurity is a constantly evolving landscape, with new threats and vulnerabilities emerging every day. Staying ahead of the curve requires continuous learning, experimentation, and collaboration. Embrace the hacker mindset. Be curious, explore, and never stop learning. But always remember to use your powers for good. Let's work together to build a safer and more secure digital future for everyone. Thanks for watching and learning with us. Drop a comment below if you have any questions or suggestions for future videos. We value your feedback. Cyber Defense.